we've got a real problem with math education right now. Basically, no one's very happy. Those learning it think it's disconnected, uninteresting, and hard. Those trying to employ them think they don't know enough. Governments realize that it's a big deal for our economies, but don't know how to fix it. And teachers are also frustrated. Yet math is more important to the world than any point in human history. So at one end, we've got falling interest in education in math, and at the other end, we've got a more mathematical world, a more quantitative world than we ever have had. So what's the problem? Why has this chasm opened up, and what can we do to fix it? Well, actually, I think the answer is staring us right in the face. Use computers.
Ladies and gentlemen, I set out to solve a simple calculus problem this evening in review for a test. And this is legitimately all of the work required to solve this one simple looking problem. All of this. Now, ask yourself, what did I gain from this? Did I gain a deeper appreciation for math and numbers? No. Did I gain a deeper understanding of how the problem works? Yes. But ask yourself this, do I ever need to know this? No. In fact, really the only thing that this problem has given me, even in the short or long term, is mostly just a headache and a fear of calculus. Okay? So really, I could do all of this work to arrive at the answer here, or I could plug this into the computer, have the answer in a fraction of a second, and continue on with what I was trying to figure out. Because in reality, nobody comes up to you with a math-related question and asks, what is the integral of x squared minus 2x minus 1 over blah, 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 blah. It's always something like, okay, you know, Farmer Jim Bob has 18 feet of fence that he needs to optimize. How would I do that? And that is actually a real calculus application. So, again, ladies and gentlemen, have I gained anything? Yeah, like that's what I'm saying, but... Okay there guys, so this is Mitchell. I'm going to go ahead and give you guys a little bit of a tour of what Wolfram Alpha can do. So, as hopefully we've explained, Wolfram Alpha is kind of like a Google, but for all quantifiable information. So let's go ahead and give it something simple to start with. Give it 2 plus 2. And you can see that it not only gives you the result 4, but it also gives you a bunch of other information, like the number name right here, gives you a visual representation, and it even plots it on a number line. Okay, so let's give it something a little bit more mathy. Let's say x plus 6 equals 8. And you'll see that it'll plot that solution for you. It'll tell you what the answer is. But if we're going to... The cool part about Wolfram is that we can move away from math and start to ask it some really crazy stuff, like, when's the next solar eclipse? See, so it'll interpret our input as the next solar eclipse after today, and then here's our answer right here, 6:52 Sunday, May 20th, 2012. It looks like it's kind of coming up pretty soon. You might want to mark your calendars. Alrighty there. Yeah, that was really lame. I'm sorry, I get a little cheesy, I suppose.
You sound like a pilot.
Yes, I do.
Ow.
So
you might want to mark your calendar.
So it can even give us some chemistry-related stuff. Like if we type in caffeine, it'll give us the structure diagram here. It'll give us a 3D diagram, which is pretty cool, especially if you're a chem major. You might want to remember that. If you really want to get extremely into math, it'll integrate functions. Right here, it'll plot it on the line for you. I mean, really, there's a whole... you can really ask it even crazy stuff, like, let's say 30 days after George, if I can type, George Washington's birthday. So Wolfram Alpha can make assumptions about
what it is you're exactly looking to find. It hears George Washington, and it knows you're probably talking about the first president, considering he's more popular. And then it asks for its date of birth, and then to add 30 days to it, which apparently is March 12th, 1732, according to the Julian calendar. I have no idea what that means. I'm probably going to have to Google that later. Of course, Wolfram
But you
Alpha.
should Wolfram Alpha it
Right.
instead of Googling.
I think the goal of Wolfram Alpha is mostly to take any information or query you can give it and spit out an answer to you that is in some kind of quantifiable form. And I think that ultimately is what makes it a true computational knowledge engine.
On page 182 of The Shallows, Carr tells us, the internet provides us with a much more capacious memory while clearing out space in our brains for more valuable and even more human computations. I feel that this applies to Wolfram Alpha because really what it does is it strips away the computation part of math. You see, math is all about asking the right question, turning that question into something we can solve, computing the answer, putting that mathematical answer back into something that we can use, and then verifying our answer. And step 3 right there, the computation process, is what we spend 90% of our time learning as children. I mean, I think everybody can recall back to when they were doing multiplication tables and having this drilled into their heads. And no one's saying that that should be removed from our curriculum, because there are times when you know, at the store, you're going to need to multiply things in your head. You know, a laptop won't always be easy for you to get. But when it comes to the more complicated areas, like even just touching on some of the basic algebra subjects, why are we teaching kids to solve these equations when in actuality, if I have some wordy problem for somebody to solve, all that they're going to want to do is put it in a computer anyways, even if they know how to solve it by hand. Simply because a computer can tell us much more about the problem than we can do simply with algebra by hand, and because the answer comes faster than you can ever do it, no matter how much you practice. So it really takes math, and even by adding the machine element to it, it makes it more human because it removes all the mechanical components.
So I really hate math, and I hate doing math. So when it comes to making even the most minor calculations, I pull out a calculator. So when it comes to things like transferring or translating military time into civilian time, I don't understand what 1900 means because I'm too lazy to subtract the 12 and figure out that it's 7, right? 7? So, when it comes to calculating things, it is important for you to know the basics, because without the basics, then you can't build on it. And even if you can find a shortcut like a computer that's going to do it for you, you lose depth and understanding if you're not doing all the steps yourself. Nicholas Carr in The Shallows says, when we outsource our memory to a machine, we also outsource a very important part of our intellect and even our identity. Outsource memory and culture withers. We're losing part of our humanity and part of what makes us such an intelligent species when we figure something out and build it from the ground up. When we don't understand where it came from, we can't really understand the whole scope of it.
So I believe critical reform we have to do in computer-based math. We've got to make sure that we can move our economies forward and also our societies based on the idea that people can really feel mathematics. This isn't some optional extra. And the country that does this first will, in my view, leapfrog others in achieving a new economy even, an improved economy, an improved outlook. In fact, I even talk about us moving from what we often call now the knowledge economy to what one might call a computational knowledge economy, where high-level math is integral to what everyone does in the way that knowledge currently is. We can engage so many more students with this, and they can have a better time doing it.